Hey guys, this is part 1 of your Unit 8 test review. Sorry, I don't remember where we were. And we're going to be working, obviously, with patella, special right triangles. So basically this covers special right triangles, sine, cosine, and tangent, the inverse functions of that, and angles of elevation and angles of depression. Okay? So let's start here. First, we can find RT, which is right here, by doing 25 squared minus 24 squared equals A squared. We'll just call this A. Because that's the Pythagorean theorem, right? We can just figure that out. And that ends up being A equals 49, or A squared equals 49, so A equals 7. Okay? Now that we have that, we can figure out, we can say that sine of R, that's this right here, opposite over hypotenuse, is 24 over 25. The cosine of F, that's this right here, is adjacent over hypotenuse, so 24 over 25. And the tangent of R, is right here, opposite over adjacent, is 24 over 7, right? That's just a basic introduction to remembering to use your Pythagorean theorem. You know, that doesn't go away just because that was a previous unit. And what sine, cosine, and tangent really mean. Okay? So let's get down to some real problems. So we have to find the value of t and s, round the decimals to the nearest tenth. We're told that. Okay, so first to find t, or let's do s first, because that comes first. This is, for angle 23, this is the adjacent leg, this is the opposite leg, and this is the hypotenuse. So to find s, we're going to use cosine. Okay? So the cosine of 23 degrees equals s over 34. Multiply both sides by 34. Right, so now it's 34 times the cosine of 23 degrees, which, if you put into your calculator, is 31.3. In order to find t, we see opposite and hypotenuse. So we're going to do sine, right? So of 23 degrees equals t over 34. Multiply both sides by 34. Once again. So 34 times sine of 23 degrees, which equals 13.3. Okay? Now let's look at number 6. This is the angle that we're given. So this is the adjacent leg, the opposite leg, or no, this is the hypotenuse, sorry, the opposite leg, and this is the adjacent leg. So in order to find R, which comes first, we do, let's see, we're given the adjacent leg. So let's first find the hypotenuse, right? So adjacent and hypotenuse, that's cosine. So cosine of 36 degrees equals 4 over R. Multiply both sides by R, right? So then this can go away. And then R is over here. Then we divide both sides by the cosine of 36 degrees. So you would calculate cosine of 36 degrees. And that's 4.9. Alright? Now let's look at F. So we have opposite and adjacent. Guys, because we rounded R, alright, that's not like a whole number. I personally do not like to use it when I'm trying to find another variable unless I have to, because it tends to be a bit inaccurate because we rounded. So if I were you, I would continue to use this, just so you know. So this is opposite adjacent, so that's tangent. So the tangent of 36 degrees equals S over 4 times both sides by 4. And we end up with 2.9. Okay? I'm just going to clean up a little bit here. Okay. So for this one, we're told to solve for x. So adjacent, this is our right angle, opposite, and hypotenuse. We're given the opposite, and we're told to find the adjacent. So we're going to use the tangent of 40 degrees equals 5 over x. Once again, we're going to do that thing where we multiply both sides by 5. We divide both sides by tangent of 40. We end up with x equals 5 over the tangent of 40 degrees. Don't forget to write your degree sign, guys. Alright, so we end up with x equals 6.0. Alright, when you're rounding to the 10th place, this is what you do. So if it's like, I don't remember what it came out to be, but if it was like 5.99, that rounds to 6.0. Okay? Alright, let's look at number 8. Once again, we're told to find x. So this is our hypotenuse. This is our adjacent, and this is our opposite. We're told to use adjacent and hypotenuse, right? So we do cosine of 22 degrees equals x over 150. So we do 150 times the cosine of 22 degrees, and that equals 139.1 centimeters. Okay? So that's how we would do those ones. Let's do the next part. Numbers 9 and 10. Okay, for these we're going to use special right triangles. I know it says to round to the nearest 10, but I don't want you doing that. I want you to leave it as is because we're going to use our special right triangles. Alright, so for this one, this is the 30, 60, 90 triangle, and the rules for that is we look at the short leg, so this is just the short leg S. The hypotenuse is 2S, and the long leg is S times root 3, right? So W is what we're looking at first, and that is our hypotenuse, so 2 times S, so W is 20. And V, which is our long leg, is S times root 3, so that's just 10 root 3, okay? And then put that, sorry. Okay. If you were to put that into your calculator, you would get, let's see, 17.3. Okay? Alright, for this one, this is a 45, 45, 90 triangle. So this is a leg, this is a leg, and this is our hypotenuse. Okay? So this would also equal 10, right? That's one of our rules. So R equals 10. And the hypotenuse is L times root 2. So that would be 10 root 2, which if you put that into your calculator comes out to 14.1. Alright, so that used our special right triangles. Guys, knowing the rules for special right triangles is important. Alright, it's not just about So like if you use sine and cosine, yes, you can do that to find S and R for this. You totally can, and that's legitimate. But it's going to take a lot longer, and when we ask you, which we will, to not put it in decimal form, to leave it in radical form, that's going to be really hard to do if you don't know these rules. So just keep that in mind, okay? Try and memorize those. They're not too bad. All right, let's go to the next page. I'm going to skip 11 and go to 12. All right? Actually, I'm going to skip 12 as well and just go to 13. 12 is very similar to what we did at the beginning. So I think you guys can do that. All right, number 13. Find the missing side of the triangle. No decimals. Leave it exact. This is our special right triangles, right? This is a leg, this is a leg, so this is 5, right? These are equal to each other. So this is L, and this would be L, and this is L times root 2. So x equals 5, and y equals 5 root 2, right? This is our 30, 60, right? We know this is 60 because these two have to be complementary. All right, so 30, 60, 90. This is our short leg, S. The hypotenuse is 2s, and the long leg is s times root 3. So our s is 6. So our x is going to be 12, and our y is going to be 6 root 3. Okay? So let's go down to number 20. All right? All right, a kite, we need to draw this by the way, is flying 70 feet above the ground and is attached to a string tied to a stake in the ground. So this just means this is the ground, there's something coming out of the ground holding the string to the kite. Here is our kite. I am aware that I cannot draw. Thank you. All right, here's our kite string. All right, pretend that's a straight line. This is 70 feet. All right. Just going to straighten this out a little bit. All right. Then with the ground, the angle of elevation, right, formed by the string and the ground is 40 degrees. So that's what this would be. Like this imaginary line making a right triangle, right? Find the length of the string to the nearest foot. Well, now all that we have is a right triangle, right? And we know how to solve this. You know, this is our angle, this is our hypotenuse, this is our opposite leg, and this is our adjacent leg. It's asking us, it's flying 70 feet above the ground. I'm sorry. This is 70 feet. All right, 70 feet above the ground. It's asking us to find the length of the string, which is this. So it's asking us to find the hypotenuse. So we're going to use sine. Sine of 40 degrees equals opposite over hypotenuse. So 70 divided by the length of the string, which is s. All right, we're going to do that fancy thing, and we know s equals 70 divided by sine of 40 degrees, which you would input into your calculator and get 109 feet because we rounded to the nearest foot. All right, so that concludes part 1 of the video, and go to part 2.